Hey, what's up? It's Jake from Nimbus DevOps, and now we're going to get into secrets. And we'll do that by going over random numbers, token generation, and finally digest comparison. So let's get into it. Um, Secrets, there's a small module added in Python a couple years back. It deals with those three things, the random numbers, tokens, and digest comparison, and it uses the most secure random number generator provided by the underlying operating system to generate tokens and random numbers suitable for cryptographic apps. So, what does that actually provide? Let's make a file, and we're going to call it secret underscore rand.py. And I'm going to use three functions to deal with these random numbers. So, first, let's import secrets, and then we're going to print secrets dot choice and then choose one of these words, and then we're going to split that, and then we're going to print secrets dot rand below 10 to the sixth power, and then print secrets dot rand bits in 32 bits. Print secrets dot rand bits 32 bits. Yep, there we go. So the first one, choice, picks that's on line 3. It picks an element at random from a non-empty sequence. The second, ran below, generates a random integer between 0 and the argument you call it with. And the third, ran bits, generates an integer with the given number of random bits in it. And if we run this code, we should get something like this. Let's see, print. What is this? Why are you mad? Because I don't have a closing parenthesis. All right, so let's go ahead and run this and see what we get. So secret RAM. So I get these, which is just a random word, and then I get this ran below value, and I get a ran bits value. So you should use these functions instead of those from the random module whenever you need randomness in the context of cryptography. So if you've ever seen random as a module, this would be the best one to use for cryptography, is using the random in the secrets module. These are specifically designed for this purpose. Okay, so let's see what the module gives you for tokens. So in here, let's just do some more, and we'll just print secrets dot token underscore bytes, and we'll pass 16. And then we're going to want to print secrets dot token, and we'll do the hex, and we'll pass 32. And then print secrets dot token URL safe in 32. Save that. Now the token bytes function just returns a random byte string containing the specified number of bytes. So in this case, it's 16. The other two do the same thing, but token hex returns a token in hexadecimal format, and token URL safe returns a token that only contains characters suitable for being included in a URL. So let's see what that looks like. So run it again. And there you go. And I will go ahead and comment this out just so we can see just specifically those three. Clear the screen. And there you go. So we got our token in bytes, we've got our hexadecimal notation, and then we've got characters that would be safe to pass in a URL. And you've probably seen this if you ever look at a URL and you see all kinds of weird characters after a URL, and that's exactly what that's doing. So how can you use this tool to write your own random password generator? Well, let's try. So let's make a generator. So in here, I'm going to make it called secret underscore gen for generator .py. And so we'll start out by importing secrets, import secrets. And we're also going to say from string import digits and the ASCII letters. And we'll make two functions. So we're going to make a password generator and then a secure password generator. So we're going to say define generate underscore pwd, and that's just going to be of length equals 8. And our characters are going to be digits plus ASCII letters. And we're just going to return dot join secrets dot choice for chars or characters for C in range, whatever the length is. And then our second function is going to be generate secure password, which will take a length of 16, and we're going to require 3 uppercase and 3 numbers, so digits equals 3. And all we have to do is say the password equals whatever generate password length is, and then we'll do some logic here. If any C dot is lower for C in password, and some C dot is upper for C in password greater than equal to upper. Get this right here. There we go. And sum of C dot is digit for C in password greater than equal to digits, then we want to return password. Oh wait, let me move these over. Boop, boop, boop. There we go, return password. So then all we need to do at the end is just print generate secure password, and then we want to print generate secure password, and then we'll say length equals 3, upper equals 1, and digits equals 1. Like that. So our generate password function just generates a random string of a given length by joining together length characters, however many that is, picked at a random from a string that contains all the letters of the alphabet, lowercase and uppercase, and the 10 decimal digits. Then we define the generate secure password that simply keeps calling generate password until the random string we get matches some simple requirements. The password has to be length characters long, have at least 1 lowercase character, and uppercase character, and digits. So, and we defined that in the last line. If the total number of uppercase characters, lowercase characters, and digits specified by the parameters is greater than the length of the password we're generating, we can never satisfy the conditions. So in order to avoid getting stuck in an infinite loop, we put a check clause in the first line of the body, and we raise a value error if the requirement can't be satisfied. And so if we want to do that here to make sure that that's not going to happen, actually this is my if. I want to make this my while loop. And then under here, define generate password. Let's do this. Let's say while true, and then do it this way, and then say if any blah 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 blah, and then we'll indent that like that. And yeah, that should work. So then up here I can just say if length is less than upper plus digits plus 1, then raise a value error, and we'll just say something like nice try, and that'll be it. I can go ahead and get rid of some of this dead space. Yeah, that should work. So yeah, that looks good. The body of the while loop is pretty straightforward. So we're going to generate the random password and verify the conditions using any and some, and then return true if any of the items in the iterable is called and evaluates the true. So the use of sum is a slightly trickier way to do it in that it exploits polymorphism, which we learned about in a previous video. So the bool type is a subclass of int. So when you're summoning an iterable of true or false values, they will automatically be interpreted as integers like 1 and 0 with the sum function. And that's an example of polymorphism. So if we run this, then what do you think will happen? Well, let's go take a look. Python secret gen. We get an error. Module secrets has no attribute choice. Did you mean choice? And then it says line 6, and I go to line 6, and I go here. There you go. Review on reading tracebacks. Okay. Did you mean is upper? Line 14. 14 is upper. Always learning how to read tracebacks. And there we go. So the second password is probably not very secure. So one common use of random tokens in the password reset URLs for websites, which we can go over an example of that, would be to generate some crazy URL, which we can do. And we can just, let's do secret underscore reset dot py, and we'll say import secrets, and we'll say define get underscore reset underscore password underscore URL, which takes an argument of token length, and we'll make it 16. And in here, all we're going to do is say the token equals secrets dot token underscore URL safe, and then just pass in our token length. And then after that, we're going to return f string https://example.com or whatever your domain is /reset password / and then we can use brackets and just pass our token. So then if you want to see it, we can just say print get reset password URL. So if you were making a URL where someone could reset their password, you could do that this way. And let's see what that looks like. So we want to do a password reset. Function get reset. So this is some weird address, right? So we might want to make this a little bit different. So let's see here. How can we change this? Well, we can change this by calling the function like that. There we go. https://example.com/reset password / some safe URL string. And there you go. So the last thing is to wrap this up is on digest comparison. So it's probably kind of surprising, but the secrets module also provides a compare digest AB function, which is the equivalent of comparing two digests by simply doing A = B. So why does it provide that? Why would I say it's surprising? It's because it's been designed to prevent something called timing attacks. So these kinds of attacks can infer information about where two digests start being different, according to the time it takes for the comparison to fail. I mean, people do some crazy stuff to figure these things out. So if you look at compare digest, the function compare underscore digest prevents this attack by removing the correlation between time and failures. So it's a pretty brilliant example of how sophisticated attack methods can be. And if you are kind of surprised by this, maybe now it's a little bit clearer why we said never implement cryptography by functions by yourself. And just it's not part of this function, but I'll type it out. There's a compare underscore digest singular like that, and you can use that. So that's it. So that is basically an overview of a quick tour of the cryptographic services in a Python standard library. So from this point, we'll go ahead and stop, and we're going to move on to JSON Web Tokens.